So to be clear, this is a second shot of this one. I didn't like the other one, so I'm throwing it out and starting over. Tried to make it a little cleaner, hopefully more understandable. That's great. And this whole thing about turning networking on its head, that's the idea of, when the sender starts sending, it has absolutely no idea about anything about this. It has no idea if it's only going to stay inside the local network. Is it going to go and do, is it going to be routed to another segment? Doesn't know, doesn't exactly care. Sure, on an application level, you may care, and there may be a whole layer that's on top of this, making sure that it works. But unlike when I send a GET to a web page, I really care if it gets there. It's really important, and I know immediately that this is, as soon as DNS resolution completes, that this is not my local segment, so I need to go hit the router. Right? Multicast doesn't work that way. Keeps it entertaining, right? Okay. Oops. Let's go. This is why you're listening to me, sort of, and I've spent at least the last 5 years doing designing, building, and supporting multicast networks in an enterprise. Okay, IPv4. Yeah. And this is just a general, kind of boils down to nobody's supporting this. This is my own work. This is not, even though I'm basing this on Cisco equipment, they haven't endorsed it, right? They're not paying me, they're not providing anything interesting. There you go. And I'm just always, I'll be clear, if there's technology, like when I talk about bidirectional PIM, that I don't have a lot of experience with it. So, when I tell you something and I'm like, this is really important, that's great. I'll be clear if I suggest additional research before moving forward. Okay. Multicast is, if you've watched all these things, you're now going to have this down. You can probably repeat this thing. It's group. It's addressing a group of destination computers. 0 or more is a group. 0 or more. Okay. And we're just trying to bring everything together. And then the real question is, what don't I understand? So by the end of tomorrow's segment, that you'll be able to come back and say, hey, can you talk more about, and I may refer you back to a lesson if you're like, I don't remember you talking about that. Oh yeah, we talked about it in first half part 2 or whatever. So that's kind of the game plan with this, okay? Again, this one always, do I have a new variation on this one? I will say with time, so say your boss says, we got to extend this out. We need to put a break on this thing. We're going to extend it out for 3 months. And you're like, oh, and it'll be like, great, you can save money on it. And the answer may be no. If, for example, I have contractors, construction people, right? They may need to have to extend the contract. They may want to get some sort of retainer to pay for their guys to be idle. So to kind of cover their idle time and then to make themselves available at this later date. So it may cost you more to extend it. It isn't always, earlier is more expensive, longer is less. It may not be, right? So you touch any one of these legs, the one or two of the other ones are going to adjust. You can't saw one of the legs of the stool and then expect it to work. This picture, you've seen it now bunches of times. Unicast on the left, multicast on your right. Okay, that graph again, that's really perspective from the sender. He goes out, he's keeps adding more bandwidth. Those are your ranges. This is important to keep, just bear in mind. I mean, you'll see that range, 224 through 239. It pops out to you, hey, that's a multicast address. You can go to IANA and look up for at least a registered one. So particularly the lower range, that 224, 00, and 01 range, you can see what it is. And I showed a couple other ranges, source specific and administratively scoped. That's yours to play with, that last one, okay? And then that huge reminder I'm constantly drilling into your head is it's never, ever, ever source address. Never, never, never. Always a destination. Nobody owns the address. The group does. You know, think of your, like, you know, if the players on the football field, they're the team, but no one is the team. Even, you know, even though you have a big star player, put a big star player and the rest of them are a bunch of losers, they're not going to make it, right? Can't run every ball, can't throw and catch every ball, right? So the team is the team, right? It's not any individual, right? No one's going to have, even though they all have that name on their jersey, it's not who they are. They have their own name, they have their own number, right? It's different. They have a unicast, right? Number 11, that's you, right? IGMP, we talked about that. That's in that, really it's most involved with the last hop. So between the receiver and the last hop router. We talked about the different versions, right? You really don't see V1 anymore, and that's a good thing. V2 added leave so we can stop sending traffic sooner. And then V3 source specific takes RPs out of it, but does, if you're doing a lot of source specific, you do add a lot of overhead of having to track all these different source group pairs. If you're doing that much multicast, even any source doesn't necessarily help, just because you're still tracking source group pairs, assuming that I'm in the path of it. If I'm out of the path, I don't care. My little branch office, we're doing none of this multicast traffic. I know none of this, right? And then there's some equivalencies with IPv6, and I'm going to do a module on IPv6 because I think I should. Okay, and then we went over this early on. This is the idea. IP address is 32 bits long, MAC address is 48. I take off the first 25 bits on the MAC address. That's my organizational identifier, this 01005E, and I steal that one extra bit, not just 24, but I steal 25 bits. Okay, so I map out, you know, there's 8, 16, 24, 25. That gets set to 0. What it means is that this, when I map these MAC addresses, right, we're stealing the last 23 bits. So most of this, the last 2 octets come over clean, right, in hex. So there's a little bit of, you got to do a little work for that, yeah. But in the third octet, there's that 128 apart, right? So 72 plus 128 is 200. So if this was a 0 on the bottom one and this was 128, they'd still look the same their max would be the same. Okay, but remember, it only matters where you actually have on the same VLAN. So we're actually going to see the MAC addresses. You're going to use 2 groups that overlap like that. If you design right now, sometimes people have these things where they have this giant campus user VLAN. We just dumped everybody in. I've seen /16s, as large as /16s. Actually, I had a /8 once. I ran into a /8, a 10/8, really. Right? Just dumped everything into a giant user VLAN. You may have a lot going, and that may become a problem. If you have small, chunked up user VLANs per closet, less likely you're going to end up having to do this, right? But this is the design consideration. And remember, the only reason you're doing it is because that way, assuming I don't have an IGMP aware switch, that this traffic's getting flooded, I hear it, I'm going to take it further into the stack because I got it on layer 1. I have to start listening to it. The MAC is something I'm interested in, so I have to start processing a little more, and then I get up to layer 3 and yeah, no. These commands are essential, right? The first one, clearly, because multicast doesn't route. If you're really going to route multicast, if you're only doing like a routing protocol and you're using multicast because it's EIGRP or OSPF and you're on a shared media like Ethernet, and does it anyway, you don't have to do anything. But if you're actually going to route, so I want to run multicast NTP throughout my network, whatever my particular application requirement is, boom, got to be there. And then the multipath is so far, haven't seen any problems with it. It's there, particularly for equal cost paths, that you'll have weird outages if you don't do this, okay? And I say weird because it was working, and then you did something like you rebooted a system and then it's not. Like, how did that happen? Oh, the hash changed and went a different unicast path, multicast. So when it came in, when it then completes the loop, the far end says that traffic's not supposed to come through that interface. So I'm blocking it, I'm dropping it, okay? We talked about this a couple segments ago. The idea is I can put some boundaries to keep multicast traffic from leaking out. That's useful. You need to be careful with your RP design because I can't stick my RP across the boundary for a group that it needs to, that it's representing, that it's authoritative for, that it's the rendezvous point for. I can't have this in between. I can't, this filter auto RP, if you're doing auto RP, and especially if you have multiple RPs and you've done a hierarchical, particularly kind of arrangement, or I need to keep traffic into different segments, this filter auto RP is really useful. At my campus, I have an RP. I put that on the boundary edge as my auto RP announcement goes out. If I'm announcing segments that it can't pass it, it'll clean those out of the announcement. Everybody outside my campus doesn't know that I'm an RP for this. It works one way, at least in my experience. Okay, if somebody from Cisco says, no, it's really supposed to work two ways, I'm like, They might tell me, oh, we didn't work right in versions prior to blah. Okay, and design these carefully. Think about it. HSRP, and I talked about how the DR is the one who's doing the PIM joins. You can control that. It's normally chosen by the highest IP address of the two on the HSRP pair. They're native, not the HSRP standby, the HSRP address, right? It's their local address. I can control this PIM DR priority, and as I said when I introduced this, that I know Cisco is supposed to allow it to do tracking essentially against it, to be able to control this, and I haven't seen it when I last looked through the documentation in in the current version. So if they are, it's great. If you find it, that's awesome. You can manually do this, but or you can leave it to do it on its own. Okay. I introduced this concept Friday, and I did a really lousy job with it, a horrible job actually with it. So what do I mean by an orphan VLAN? So here's my kind of scenario. Here's what it looks like. So I have a router and a switch. On switch, uplink is built as an access port. Okay. I need to add a new voice LAN, so I create the SVI on the switch. Okay. I enable routing between the user VLAN and the voice VLAN on the switch using a routing protocol such as the EIGRP. Could even be static, really, as long as I do the static routes enough, right? Get it all the way through to the router. Okay. I don't have any demand for multicast on that user VLAN, no use for it, right? Where do I enable PIM? On the voice VLAN SVI, well, if I need to do multicast on that voice VLAN, absolutely. Have to, right? How does it get to the router though? So you think about it, so if I enable on the router's uplink, that's cool, but how does a packet actually flow? So if I'm routing a packet, it comes, on that LAN hits the SVI. SVI is then going to route it to the interface on the switch for that user VLAN. Okay. If that's not PIM enabled, it can't hand it off to the PIM on the router interface. It's not going to pop over into that user VLAN because you have not enabled multicast on that user interface. And what other configurations do I need? Well, I need to, this one I think should be straightforward, right? You're going to turn on multicast routing. You probably didn't before because the switch was a dumb switch. It was just, you may not even have routing turned on. If you have your old 3750, you may have not built it with routing. You just gave it an SVI for management interface, and you put a default route in, and you're like, I'm done, I'm good. So turn on multicast routing on the SVI on the switch port. Now, I'm a big believer. I hate these designs. I do. Assuming the place has some off hours, I'm going to do a change. I'm going to, if it's remote, I'm going to do shutdown in, so I can tell it to shut down in 5 minutes, to reload in 5 minutes. I'll go in and on the switch side, I'll rebuild the interface as a trunk and then fix it on the router side and have it now build as a trunk. So I've now trunking the user VLAN, and then I'll go ahead and build the voice VLAN on the router. Right? If I can do that kind of design, that's how I do it. But I call these orphan VLANs. I had to troubleshoot this with someone once. They're like, no, this isn't working. I'm like, hey, how is it getting from A to B or A to C really? She go, well, it's A to B. And you're like, no, it has to go on the switch from the voice VLAN to the user VLAN, right? That's what I meant. Okay, here we go. We don't have time. We're good. We're going to get through this part. May not get fully into the quiz part today. That may go for tomorrow, but that's fine. If you need to slow down, you can chat, say, can you slow down? Also, feel free to, watch the video again. See, the fun when I'm doing videos, I talk my hands. Okay. So first point on layer 1, IGP snooping is normally enabled by default. You can turn off for troubleshooting, and the vendor may ask you to do that. And in fact, if a vendor doesn't, and you're having this thing, well, I have like this device is working and it's on the same VLAN as the other one isn't, turn off snooping. Just turn off snooping, try it. You can even look and make sure if you have a packet capture somewhere, you can look and make sure that it's flooding. Another one of your tests simply is like if I can mirror that port and I can see the traffic on my packet capture. Okay. And it's good to verify that it's working every time I'm touching. If I'm doing troubleshooting, touching a device for the first time, I can just do that. Yeah, it's on for the VLAN I care about. Great, moving on. Okay. Layer 2, remember this oversubscription problem. It's probably not going to end up for you as a trouble ticket more than likely, but it is just kind of be aware of it. Like probably shouldn't have chose those addresses. Okay. IGP is the last hop on your layer 2, last hop on the first hop, right? The sender sends, the source sends, it just sends. So that MAC goes out. This destination is MAC. It's going to hit the router, assuming the router's multicast enabled. Well, even if it isn't, it can still hit the router, and the router doesn't do anything with it. I'm not multicast enabled. I'm not PIM enabled, so I get it. I get the traffic, but I'm not doing anything with it. That it just sends, and that's when PIM starts to pick up. We do a lot of other things, but no IGMP really on that sender side, none. That doesn't mean that it's not happening in the LAN, right? I can have clients that are receivers on the same LAN as my sender. That's legit. That can be happening. And I should have put in off of. IGP snooping is keeping the load off of the last hop router. So rather than managing all the clients, the switch is proxying everything. So I'm only going to tell you, I'm going to give you a report as soon as something wants the traffic, but I'm not giving you a leave until everybody's gone. And I'm going to even proxy your queries. So you don't need to handle a query. I'm going to take care of it for you. So I'm going to just take it and deal. Okay. And then this keeps this actually helps with layer 1. So I only need to send it down the ports that really care about the traffic, not all of them. Otherwise, it's kind of broadcast-ish. The difference between a broadcast and a multicast, when the switch is not IGMP snooping enabled, or MLD, if it's IPv6, is that it's still going to flood all the ports. The difference is I see the MAC immediately and go, I don't know multicast. I don't want this. Or this isn't a multicast group I care about. So I'm going to drop it based on the Mac, or if it's the Mac happens to match then based on the layer 3, I'm going to ignore it. Right? If it's IGP snooping's turned on, at layer 1, I don't see it unless I've asked for it. I don't see it. It's kept from me. That's great. Layer 3. Each host may subscribe to multiple groups. And that's a may. It doesn't have to. It can subscribe to 0. It can subscribe to many as it can handle. And what do I mean by that? I don't even know, honestly. I haven't seen anything where anyone said, well, on Windows 10, I've tried, I've just put in like 300 multicast groups and the thing crashed. I haven't seen anything like that. Maybe there is. Maybe someone's tried that. I have no idea. And as you see with IPv6, you start getting a lot of groups, right? Just by default, because IPv6 doesn't want to do broadcast, there's a lot of groups that just start to accrue to you, okay? And a router alone has to have at least 2 groups. Even on IPv4, it's subscribed to 224.0.0.1 all multicast hosts and 224.0.0.2 all routers. PIM is between layer 3 interfaces, sparse mode. Dense mode is not supported across all platforms. So sparse, dense, and dense mode, you just don't do anymore. If you're still running it, you got to figure out how to get off of it, because eventually you're going to have to replace this stuff. Don't count on all that stuff still being there, okay? That could get into some weird design questions, and you may need to start running bidirectional. There's other things you may need to do to make it work. Awesome, but there we go. And be careful with these orphan VLANs. So I just wasn't thinking, and I need to make sure I have PIM with every single hop. Like, but he's connected to that VLAN, right? But on that VLAN, that SVI is not PIM enabled, so it can't route from the orphan VLAN over to the other SVI to be able to go out. Okay. And then enable on every device from first hop to last hop, and everything in between, right? So any break will cause an RPF fail. So using mtrace, I can find those. Hey, and the error message does tell you not PIM enabled. Okay. This multipath, put it everywhere. If you have a configuration management system, be querying to make sure that and I would do it as conditional, where if multicast routing is enabled, that's also there. Recognize that you may need to do some variations based on platform, because of course ASRs, ISRs, Nexus don't look the same. Okay. This AutoRP listener is turned on. If you're running AutoRP, if they're going to do multicast at all, they need it. Make sure it's there. Again, so if I know I'm running AutoRP if multicast routing is enabled, I'd also be looking for that command as well. Source specific multicast setup in the last hop router that we went over in detail, I think in part 5, that it can be done only in the if you do it in the last hop router, it'll work, but do it on all of them just because it's better to do it that way, just safer. Okay. And I'd be consistent, right? So across my enterprise, if I want to do this way, that way, I do it some other way on the other part of it. Yeah, I wouldn't count on it. Clearly, if these source specific things are these little islands, so in Europe we're doing it this way, and in North America we're doing it that way, and we don't do anything in between, okay, they're doing it differently, fine. Someday somebody's going to come at you with an app, though, that needs to go from North America to Europe across multicast, and then you're going to have to deal with it. So I like to make things consistent. So that's my thought on that one. Okay, so quiz. I think we're going to save the quiz for tomorrow so we don't get into this too far. So this one will be a little shorter, which is cool. But so you can get ahead of your cheat. Yeah, I'm going to go look it up. Right. I'm not Cisco. It's not a closed book test. Right. Yeah, not a closed book test. So you get a chance to take a look at some of these questions. Hopefully the questions are clear. So hopefully that's a good start. I'm gonna go skip to the end here. This one. Thanks for watching. Subscribe to my YouTube channel. When I get enough subscribers, apparently I can get a better link. I think I also have to put a lot more content in, which I'm happy to do, but whatever, I'm working on that. And then this is how to follow me LinkedIn, where I've been typically SlideShare is where the slides go there. And then I should go back and do comments on the, I'll probably get around to that. Okay, and questions, comments, whatever, put them in the comments field, either on LinkedIn or on the YouTube channel, and I'll take a look at it. Right? If it's questions, I'll try and answer them. Sometimes the answer will be, hey, I'm going to cover that in part 8 or part 9 or whatever. Maybe, or hey, did you see, I may ask you a follow-up question, did you take a look at part 4? Is there something you didn't understand in that? And then we can have a conversation. Hope you're dealing well with what do you call it, quarantine. Yes, assuming you are. I'm hoping, you know, if you're an essential worker, you have the protective gear you want and you're getting hazard pay. If you're not an essential worker, that you're getting paid and that you're safe and you have toilet paper, food, clean water. So hoping you're doing the best. And, you know, for some reason that you're sick and you're watching this thing, particularly if it's COVID, heart goes out to you. Sorry you're suffering right now. I really, really does. My heart goes out to you. And, you know, I really hope you get better. You know, you put in the comment like, hey, I watched you while I was in the hospital with COVID. You'll get like a double thumbs up on that one for like, wow, were your sedatives not working? Sorry, I had to say that, but yeah, I hope you get better. And if you have family, you know, wishing them the best. And you know, just do what you can. If you've ever looked at Stephen Covey, you know, he talks about your circle of control, and you have a circle. You can actually control things. Like, you know, I brushed my teeth this morning. That was in my circle of control, my circle of influence. You know, making sure my wife, you know, makes her dental appointment, sort of thing. I can influence that. Stepdaughter, dentist, forget it. Doesn't happen. That's outside my circle of influence. That's outside my circle of control, circle of influence, right? That's that outer circle. And some things, you know, like who gets sick and who survives getting sick, that's outside our control. So, you know, there's a lot in that outer circle. There's truly a lot in that outer circle. When things are really good for you, so much in that outer circle went your way. It's not always going to be that way. So enjoy it while you have it. So on that somber note, let's end this and have a good day.